Hey folks, Professor Gray here, ready to talk to you about non-standard normal distributions and how to find non-standard normal distribution probabilities using tables. Now, there's more than one way to find probabilities in a standard or a non-standard normal distribution. There are two ways in particular I like to show my students. One of those is with a table. The other, and the more popular way, is with a calculator. And I'll continue to do that and indeed show both ways of solving those types of problems with the table and the calculator. This video talks about how to do it with a table. And a non-standard normal distribution is a normal distribution that is not standard. That means the mean is not 0, the standard deviation is not 1. Instead, we have other means and other standard deviations. For example, if we let x represent the height of an adult male, then x is normally distributed with a mean of 69.9 inches and a standard deviation of 3.1 inches. Notice here the mean is not 0, it's 69.9. Standard deviation is not 1, it's 3.1. So now we're not dealing with standard scores, we're dealing with raw scores, non-standard scores. Well, when we use a table, we can convert data to standard deviations above or below the mean of a standard normal distribution with the z-score formula. And here it is. Z equals x minus mu, all divided by sigma. And we typically round these to 2 decimal places. So I would take a raw score, a score that's non-standard, and convert it to a standard score using this formula. Once I've used the formula to convert it to a standard score, the process is exactly the same as it was for the standard normal distribution problems. All right, here are some examples. With men's heights distributed as described earlier, let's find the proportion of men that are shorter than 62 inches. So I have a normal distribution. It's non-standard, so the mean is 69.9 inches. Standard deviation is 3.1, as pictured on this slide. And I want to find the proportion, or the area, that's less than 62 inches. So for number 10, first my probability statement, the probability that x, now I use an x and not a z because x is a raw score, z is a z-score or standard score, and this 62 inches is a raw score, so I want the probability that x is less than 62. Now to do that using the table, the first thing I'll need to do is find the z-score. I'm going to convert 62 to a number of standard deviations or a standard score above or below the mean. Here's the z-score formula again. Now I'll substitute in x is 62. Mu is given in the problem, 69.9, and the standard deviation is 3.1. Now, if you use a calculator to find that z-score, that's perfectly fine. But I suggest that you put parentheses around the top of the fraction, the numerator. And that keeps everything in the calculator in a way that the operations will be done in the correct order. So I put the top in parentheses. I can put it on one line, and I get my answer. As mentioned earlier, we typically round z-scores to 2 decimal places. So the z-score is about negative 2.55. Now, that z-score is not my answer. Remember, I'm not looking for the z-score, I'm looking for the probability. But this z-score will help me get to my final answer, which is the probability. So it's important, but it's not my final answer. So on this scale, 62 inches is at negative 2.55 standard deviations below the mean. I know it's below the mean because of the negative. Well, I know how to look up a z-score. I just look at the table. That's the procedure. We convert the raw score to a z-score or standard score, find the area under the curve to the left of that z-score. So I go over to my negative z-score page, find negative 2.5, line that up with 0.05, and match it up to 0.0054. That is my answer. So I convert to a z-score, and that helps me find my probability using the table just like I have before. Let's do another example. Number 11, what proportion of men are taller than 74.9 inches? If I take a look at the sketch or the depiction of the normal distribution and the area I'm looking for, I see that 74.9 is above the mean, 69.9, and I want everything taller than that, so I would want the area to the right of 74.9. All right, to set that up, probability statement. Probability that x, because it's a raw score, is greater than 74.9 inches. First thing I've got to do if I'm using the table is find the z-score. Here's the formula for that. Substitute in and solve. X would be 74.9. That's the number I'm interested in. Subtract the mean, divide by the standard deviation. And we'll round that to 2 places. So my answer is approximately 1.61. Again, this is not my final answer, but it is an answer that will help me get to my answer. The process will be that I will look at the z-score table, find the area under the curve to the left of the z-score, and then I'll use complements to find the area to the right. All right, here's my positive z-score page. I go to 1.6, line that up with 0.01, and I get 0.9463. So 1 minus 0.9463 will be my answer, because the z-score pages only give me the area to the left. I want the area to the right. So if I take what's to the left and subtract from 1, I get what I'm looking for. And that's going to be 0.0537. And that's my answer. Again, the procedure for that would convert the raw score to a z-score, find the area under the curve to the left of the z-score, and then use a complement to find the area to the right. Well, we've done the area to the left, area to the right. Let's do another example. The area between two raw scores, the probability of men's heights, or a man's height, being between 63.5 and 71 inches. Probability statement first. 63.5 less than x less than 71. Next order of business, I need to find z-scores for both of my raw scores. I'll need to convert them both. So let's convert the 71 first. We'll call that z sub 2 because it's the bigger one. You get 0.35. That's one z-score. All right, let's find another one. Z sub 1. The sub 1s and sub 2s just help me differentiate between which one I'm talking about. And I get negative 2.06. All right, those numbers are not my answers, but they'll help me get there. The next thing I'm going to do is go to my z-score table, because probability of x being between 63.5 and 71 is about the same, because of the round-off error, as the probability of z being between negative 2.06 and 0.35. And that I can find using the table. So we've converted the raw data to z-scores. We'll find the area under the curve to the left of each of those and subtract the area corresponding to the lesser z-score from the area corresponding to the greater z-score. In other words, we'll subtract the smaller area from the larger area. So here's the one on the right. 0.35 gives me an area of 0.6368. So 0.6368 minus, and the area on the left, the z-score on the left, negative 2.06, gives me 0.0197. And if I subtract the two of those, I get my answer, 0.6171. That's my answer. That's my overall final answer. And what happened there is I have my non-standard normal distribution, and I'm finding the area between 63.5 and 71. Well, if I look on the other scale, the standard normal scale, z-score scale, that area is going to be the same as the area between the z-score negative 2.06 and 0.35. I use the table to find that area. The area, of course, corresponds to the probability. So that's how to find probabilities in a non-standard normal distribution using tables. In another video, you'll see how to do it using the calculator.